Hello everyone, and welcome to I am your data scientist.com. Today I'll be going through k-means clustering algorithm, which is quite known algorithm in data science, machine learning, and also some of you have requested to record a tutorial on k-means clustering. So let's briefly talk about what is k-means clustering is briefly. So what is k-means clustering? So forget about k-means, but you can understand clustering. Clustering means kind of categorizing or grouping data set or grouping certain things. So this algorithm, also known by KNN, which is k nearest neighbor. So have you ever thought of, like, for instance, if there's lots of car passing by and you notice there are certain cars kind of frequently coming on, for example, in where I work, I see quite lots of taxi drivers, driving Toyota cars, and sometimes I notice that their colors are quite black, and sometimes it's silver color, hybrid, whether it's 2 point something liter, whether it's a saloon, SV car, so on and so forth. So this kind of this is called clustering. So you want to cluster them together on a specific category or specific values. So how can you apply k-means clustering? So clustering is an unsupervised machine learning task that automatically divides the data into a cluster or a group of similar items. So the resulting cluster can then be used to action. For instance, you might find clustering methods employed in following applications. For example, segmenting your customers who buy certain products. You can group them. For example, if some customer buys appliances, so you would cluster them together. Some would buy clothing, some would buy grocery, so on and so forth, with similar demographics or buying patterns for targeted marketing campaign. You can also use clustering to detect anomalies. So for example, like unauthorized network intrusion, so on and so forth. So if, for example, if you want to do, if you fancy doing KNN on using Excel or any other application, so you can do by using Euclidean theorem. But with machine learning, with R, you have that algorithm already inbuilt in as a package, so you don't have to write all the formulas. But for more information, you can find out what Euclidean theorem is. But without further ado, let's. I think we had enough talk on k-means clustering algorithm. Let's straight jump into the tutorial. So today I've chosen this data set of social network services. Social networking services. So you can get this data set from my GitHub. So let me just clear my R memory. Let me just get data, get working directory, set. Let me just set working directory, then check whether it's connecting to the correct directory, then assign that data set. Now let's start exploring our data. So by structure, so seems like it's got 40 variables with 30,000 observations. So it's quite a number of rows there. So which has grad year, gender, age, whether they have friends, whether they play basketball, football, soccer, volleyball, whether they go to church, whether they are blonde, whether they probably read Bible, do shopping, clothing, whether they take drugs, drunk, so on and so forth. So let's have a look at table. So table of gender. So you can see there's something like 27,000 altogether. So out of which 22,000 are female and about 5,000 are male. So the question arises, we already just have seen that we've got about 30,000 observations. So if you add these together, it's only about 27,276. So if you take away that, there is about 2,724, which is not recorded here, or some sort of missing or something. So let's have a look. This, which gives us, so now you can see there is something like NA. So NA means they left. So as you can see from here, there is about 9% NA value. There is about 73% female, which is quite significant number, and about 70% are male. So let's check the range of the age given. So you can see from minimum we've got about 3 years, and the maximum is about 106 years, and you've got some NAs here, about 5,086. They don't have age assigned to them. So as this explains, it's very hard to see anyone under 15, 16 going, or 13 going to high school, and anyone above 106 years would attend high school. I have not come across. I'm not sure about you, but it's probably, I'm guessing it's probably to do with data validation issues, or somebody mistyped something, or just maybe was in hurry, or some sort of when transposing, when kind of retrieving data, they messed up or something. So this is highly unlikely that somebody at the age of 3 would attend high school, and at the age of 106 would attend high school as well. So again, if you were to calculate about this 5,086 divided by 30,000 times, that would give us something about 17% are missing age, which is quite a significant number. So before we go ahead, we need to clean the data. So what we want to do is we want to replace anything above 20 years of age with NA. So the reason why is because you don't see anyone above 20 years of age going to high school, and again below 13 is also very highly unlikely they would attend high school. So this is how we do. So this is our data set. This is the column which we want to apply these conditions. Then if you apply that and pull that back, and here you go. So it's replaced with NA. So anything below 13 years of age, 13 or equal to age, or anything less than 20, we'll keep that age. Otherwise, you would say put that as a NA. And if you were to do it now, you get the range is quite okay now. So before it was going something like 106 and 3. Now is about minimum age is 13 and maximum age is about 20, which is quite, I think, okay. So again, so as we said before, we had about 5,523 NA. Now we've got previously we had about 586 NA. Now we've got about 553. It's about 437 was replaced with NA. So here what we're doing is further cleansing is applied. So what we're trying to do is, if gender is not female and not unknown, then obviously it's a male. So if you think about logical expression, so if anyone is not female and not unknown category, which is NA, so that's obviously it's a male. So how do you do? And again, if gender is missing, then 1 or 0. So you can see now we've got about 22,000 males and about 5,000 females. Sorry, males. If you were to put that into, if you were to remove NAs, it will give us about 7,900 something, which is male, and about 22,054 are female in our data set. Same with the gender. So we've got about there are about 2,724 has no gender at all, whereas 27,000's got gender. So which is, I think, these two numbers should marry up. This number plus that number, male plus this number should tally up to 27,000. And let's check age again. So okay, so age has NA, so you can't calculate an average. So what we do is we take the NA equals true. NA means NA dot RM. RM means remove. So NA value are trimmed before calculating the average, and the average is about you can say 17%. Sorry, 17 average. So now let's aggregate this data by, if you want to find out average age per year. So this is how we do it. So there's a function called aggregate. Then into assign your data, then the age you want to calculate and the groups you want to aggregate for or group by for. So in SQL, if you want to say, give me all the age group by year. So this is how we would do it. So in 2006, about average age going to high school was 18, and 2007 number was about 17, 2008 was about 16, 2009 about 15. So you can see as year increases, the age of average age of children going to high school decreased. Not sure why that is. Maybe students start school early, or they're pretty smart. You don't know what's the reason behind that is. Okay, so just for fun, let's calculate average age by gender, the same thing applies. So there's no much difference really. It's a 17, 17. So I would take the mean average of the whole data set is 17. So I would take that. So you would consider that average person would enter into high school at the age of 17. Let's apply a function, age function. So you can see it's giving age and sticking that onto our data set. And let's put summary. Now you can see there's no any missing values or anything. The minimum age is 13, the maximum is 20, and you can see the mean is 17 and median is about 17. Same. It just happened to be that the median and the average both are same age. Did not need to be. The mean is calculated differently, and median is also calculated differently. So mean is the sum divided by number of observations, whereas the median is the position, the middle nth position, and divided by 2 positions. So if you have 50 observations, divide by 2, which is 24th and 25th observation. So this is how median is calculated. And so I'm sure you know first quartile and third quartile and all that. I just want to have fun here. So just for fun, I can calculate the same thing for gender. Let's now. This is the main part of our K-means clustering. So let's have a look at our structure. So you must have noticed now that we've added two columns. One is called F, female. One is called no gender. So before, remember, we had about 40 observations. Now it's got 42 observations. You can see 42 observations, 42 variables, and 30,000 observations. So why am I choosing from 5th column to 30th column? Because if you're to, I've literally copied these to here just to make it more clear and just to explain. So if you was to number them together, number them 1 to 43, 40. So you can see from first is graduation year, which is in year. Second is gender, which is character. Third is age, which is normal age. Probably it's between 13 and 20. Whether they've got how many friends, number of friends they've got, social media friends, whether they play basketball, 0s and 1. If they play basketball, 1. If not, 0. If they play football, 1. If they don't, then 0. So on and so forth. So why I said from I want vector from 5th column to 30th column. So I said I want from there. I want nominal values. So I want Boolean values, 0s and 1s. I don't want higher numbers. So if I was to add, if I was to add age and friends and grade years and all that, that would make it would skew our data. So this is why I said, give me all the columns from 5th column to all the 30 columns, and I said take away all the other columns. For example, 1, 2, 3, 4, and 5. So 4, I'm taking out 4 columns plus the other 2. So 6. So I'm taking out that 6. So that's why I said from 5 to 30. So before you even begin with your K-means clustering, first you need to do is you need to normalize your data using z square. I'm sure you know what z square is, or sometimes we call it z square. It's to normalize data. If you see bell-shaped curve, if you're to apply this z score, and if you're to plot this, what it does is it will give you nice bell-shaped curve, which means the mean value is 0 and the standard deviation is 1. So let's do that. Okay, saying okay, and called in. So k, and I'll say kz, and start with any random number, and I wanted 5 different cluster. Now let's evaluate. This is just for fun, really. So this is the main thing I wanted to show. So here you can see it's got 5 different clusters for each variables. 5 different cluster for each variable. As you can see from the 5 different clusters, you can see the first one is quite higher than the other clusters in any variables. So so on average, you can see this is very high cluster, whereas I think number 2 is slightly negative, coming out to be. Another way to see the size of each cluster is to so just to see how many observations are used for each cluster. So there are 5 clusters. So first cluster has got 5,000, second has got 22,000, third has 246, so on and so forth. So the second cluster is quite it is quite big cluster in itself. So now we have looked at the clustering. Let's try and improve our model performance. See if we can improve any our model performance. So I want just the first 5 rows. So what it gives us is the cluster-wise gender average age. So second cluster has got male, average age is about 19, has about how many friends? 7 friends. This guy is quite famous. I think this child, this teen, has got 69 friends. Probably social media links. So let's look at further. Let's see if we can further drill down this. Let's look at mean of each cluster. So each cluster, I think about 17 years of age, which is I think quite significant and quite promising, as our mean age was 17. Let's look at female. Okay, female again. It's about 79%. The first cluster uses 80%. About 80% are female, whereas in fourth cluster about 84% are female. So it is quite female dominated, this data set is. So yeah, we saw right before that the 70% of the data set was female. So what this code does is it it finds out the mean or average of friends per cluster. So cluster 1 has got 37 friends, which is, I think, on average, which is quite most than any other cluster. Then the fifth cluster has quite significant number of friends. So in this tutorial, we've looked at some key things about what cluster is, how to apply the logic behind clustering, and we just looked at the very basic of how to do clustering. So there's more to clustering KNN than just grouping. So you can really find some interesting things about certain groups of people, how they relate to each other, how they fan out, so on and so forth. This is Yogesh. I'm your datascientist.com. Thank you for watching my video. I think I'll be recording more and more data science and machine learning tutorials so stay tuned, and thank you very much for subscribing onto my channel. Thank you very much. Bye.